Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. Today we're going to be talking about light emitting diodes, or LEDs. And we're going to look at what an LED is, and then we're going to look at how we connect an LED to a circuit, and then we're going to look at some of the circuit parameters that control how an LED behaves. Alright, let's get started. So we're doing light emitting diodes, LEDs. And to the right here we can see we have some pictures of LEDs as well as a circuit schematic symbol. And so just to look at some of the features of the LED, just kind of want to point out. First off, this is what's called a through-hole LED because these terminals these leads go through the holes inside a circuit board, and then they're soldered to the circuit board in that fashion. You'll notice that one of them is longer than the other. And so we have what's called the anode and the cathode. And so they're given the positive and negative symbols here, meaning that we connect higher voltage to the anode and lower voltage to the cathode if we want the LED to turn on. And typically we would. And so when you're actually building with these, it's important to recognize that the longer one is the positive and the shorter one is the negative, so that we connect it into the circuit that we're building in the proper way. It's what's called a directional device, and it needs to be put in the proper direction. A couple other indicators that you're putting it in the correct way is the flat edge right here. And so that's flat and it doesn't stick out like the rest of the circle does. It's cut off. And so that's the negative side. You can see the flat spot right here shown on this zoomed in diagram as well. The other thing is that the two pieces inside, the metal pieces, the post and the anvil is typically much bigger. And so there's the anvil. And so you can look at that anvil and note that that's on the negative side as well. Just a couple of ways for you to kind of recognize and identify which side is the negative side or the cathode of the LED. Just an aside here about how we label anode and cathode. Cathode is defined as the terminal where positive current is leaving or flowing out of that terminal. And so on the LED here, when it's in normal operation, positive current is flowing out this direction and flowing in this direction. And so positive current is leaving the device through this terminal, so that would be the cathode terminal. And so that's how that is defined. All right, great. So here we have the symbol. It looks like a triangle, and then there's a line on the cathode side, and then we have some arrows leaving the triangle showing that this is emitting light. And so the anode side is on one of the flat edges of the triangle, and then the cathode side comes from that perpendicular line right there. Okay, and we'll be drawing those in our circuit diagram as well. Let's talk about a couple things about the behavior of an LED. So first off, it behaves in such a way that it's off until a threshold voltage is met. And then it turns on. Okay, and that threshold voltage, VTH, for an LED is approximately equal to 1.5 volts. So when you ramp up the voltage here, you have to have a voltage supply of at least 1.5 volts if you want this thing to turn on, because other than before that it won't turn on at all, and then after 1.5 volts it will turn on, and then the more current we feed through it, the brighter it's going to get, and that's our next bullet point. So brightness depends on current. Okay, so that's our second bullet point. And our current is typically approximately 20 milliamps is what a lot of them are kind of designed to work at. And the next thing is, well, how do we get it to be 20 milliamps? And so we have a current limiting resistor. We'll look at its behavior and its role limits the current. Kind of redundant there. So we set the current with the current limiting resistor, limiting it to 20 milliamps, and then it'll hit that 20 milliamps. One more thing to realize is that once on, the voltage remains at the threshold voltage instead of 1.5 volts. So the voltage doesn't increase when we increase voltage across the whole system. And that's one of the reasons why we need the current limiting resistor, is because as the voltage increases across the system, the voltage will increase across the resistor, not across the diode. The diode will remain at 1.5 volts. And so if you're into IV characteristics, what that means is that our current basically is 0 until we meet that threshold voltage, and then it goes straight up. And so the voltage stays the same, and then we just decide how much current is going through based on the resistor. So this level is set with our current limiting resistor. Okay, so that's how that behaves. Great. So those are the bullet points we want to look at. So let's go ahead and get to a blank section. So what if we connect in an LED with a 5-volt source? Okay, so that's going to look something like this. We have our source, and then we have a resistor, and I'm going to set the resistor value. I'm going to call this RCL for current limiting, and then that resistance value, I'm going to call it 220 ohms. And then we have our LED, and then we have our ground. Okay. And we know that the threshold voltage here is a certain value, and let's just set it at 1.5 volts. So here is a typical diagram for the operation of an LED. And oftentimes this will be an indicator that will be, will be powered not through a source of 5 volts, but through an output of a microcontroller or something like that. So this is an output from, say, an Arduino. Okay, and then we could connect that up and, instead of having the 5-volt source. And that will work in a similar fashion. Okay. So what we want to know here is, what is the current? So is it 20 milliamps right now? So what is that current? And we're going to use that by, solve that by using Ohm's law. So Ohm's law says that the current is the voltage over the resistance. So now this voltage, when I say voltage, this is the voltage across the element that we're looking at. And the element that we're looking at is the resistor. And so we're going to go from 5 volts to 1.5 volts. So we have to figure out what that is, right? So we know that the resistance is 220 ohms, but the voltage here is the change in the voltage from 5 volts to 1.5 volts. So in node voltages, it's 0 volts here. There's a drop of 1.5 across the diode, so it's 1.5 volts here. And then we know this top is 5 volts. So 5 minus 1.5 gives us the voltage change across the resistor, and that's 3.5 volts. So we have 3.5 volts, and we have 220 ohms. So we can find the current as 3.5 volts over 220 ohms. And if you do that calculation, you get approximately 0.016 amps, which we would call 16 milliamps. So it's not quite 20 milliamps, it's 16 milliamps, which is quite close to 20 milliamps. And so, we're in the ballpark that we're expecting to be. This 220 ohm resistor is a common resistance value that is used with LEDs to give us that approximately 20 milliamp performance. Now you can imagine if the threshold voltage here was, a little bit smaller, we would get closer to that 20 milliamps, but that's just what we're looking at in this example. So what about the power? So the brightness is related to the power, and since the voltage doesn't change, it's also related to the current in this particular case. But power is the voltage times the current, and now we're looking at the LED. And so the voltage drop across the LED is 1.5 volts, and the current through the LED is 16 milliamps, and then multiplying that, we got, 16 is 2/8, so 3/8 is 24. So this would be 24 milliwatts. And so the power that is delivered to the LED is 24 milliwatts. And then anything that goes to like heating and things like that will be removed. It's called the efficiency of the LED. And then whatever is remaining is converted into that light energy that we see and call brightness. And so there's what we have, okay? All right, remember if you have any questions, put them in the comments and I'll try to get to those when I have some time. Let's do an example. So this might be a problem that you would see on a quiz or something when talking about setting up an LED, understanding the role of the current limiting resistor and whatnot. So let's say that if we have an LED that has a threshold voltage of 1.4 volts, what resistance, so we're solving for resistance, what resistance would allow 30 milliamps of current? Okay, so we want to find out what the value of the current limiting resistor is in this case. Okay, so first thing we're going to do is just kind of redraw our circuit. Okay, so there we have it. We're looking for this R. We know this is 5 volts. I guess it doesn't say that, but let's assume that's 5 volts. And then we know the difference in voltage here is 1.4 volts. So we can find the voltage across the resistor is going to be 5 minus 1.4, giving us 3.6 volts. And in this case, we know the current through the whole thing, the resistor and the LED, is going to be 30 milliamps. That's what we want it to be. Now we can use Ohm's law again. In this case, we'll use it in a different form. So I is V over R. So we can write this as R as V over I. And so then our resistance is just 3.6 divided by an I. Now it's 30 milli. And so I'm going to convert that to 0.03 amps. So we're going to divide this by 0.03. Well, when we divide by 0.03, we can move the decimal place over 2 in both of these. So this is 360 divided by 3, which now I can see is 120 ohms. So there we have it. So resistance of 120 ohms will give us a current of 30 milliamps through the LED and the corresponding brightness that would occur because of that. Okay. All right. Well, that's all we have for today. I hope you found that valuable. I hope you enjoyed it. My name is Mike Stanzik. This is Digital Electronics Classroom, and I want to just remind you, please subscribe to the channel and like the videos. Appreciate that, and wish you a wonderful day.